Okay, I'm going to try to explain SOA, Service-Oriented Architecture, for you. That's the main focus of this unit, Unit 8. SOA is a new and exciting concept, fairly new at least. It's a different way of looking at things, but because we want some kind of consistency in user interface, we often hide from the user. So you've probably been using this many places without really thinking about it. And what I want to do here is to make it really clear how things are different behind the scenes as a big level. And then we'll drill down into some details for you, okay? Let's start with this slide that you saw before, the web, the big picture. And the basic idea here is that we've taken our traditional GUI application, something similar to what we did with the drag and drop GUI builder in Unit 6, I think it was. And we've split it into two pieces, a front end and a back end. And we've dropped the internet in between the front end and the back end. And there are a number of different ways to do this, but they all have consequences. There are consequences of trying to drop a network in the middle of your program, okay? We said that the standard choice, the standard approach to dealing with this split is what we called and discussed earlier of a three-tier architecture. Three-tier architecture, right? The tiers are a user device, some kind of an application server, and a database server. We could generalize that to be a data source, but for a long time, classically, when we talk about three-tier, it's a database. And what we do with the user device, there's nothing to keep us from putting software that we write on the user device. But if we're not careful, if we do that, then we have to deal with supporting that, maintaining it. When we make a bug fix to that code, we've got to ship a new code. The result is the classic three-tier architecture says the thing on the user device we're going to take advantage of is a web browser, and we're going to let the user maintain their own web browser. And of course, now that's become very automatic. All the browsers I know of update themselves automatically, often every few days or maybe even more often. And we don't really have to fool with it. We just sort of assume that that's going on, and we write our software accordingly. Now, the other thing going on here in this three-tier architecture is we assume everything other than the user device belongs to the same organization. We have some kind of a web page that the user accesses, and it talks primarily using HTTP, although there are some other ways to have it talk to the application server. The application server talks to a database server. But we're assuming that this whole slide is under the control of one company or organization, and that we're not intermixing, that we have control over the whole thing, okay? This is what we did primarily in the last unit, right? We did a whole thing. Our data source happened to be an XML file, but it could have been a database server. We had an application server. Let me go one more slide, actually. Here we go. Here's a traditional web architecture. It's a three-tier architecture, right? So you have a user device with a browser. It talks over the internet, primarily using HTTP. And, you know, we could use raw sockets, and we could do more creative things. But network administrators these days like to close off most of the ports on the network, on the routers, for example, and leave only a few open. One of the ones that they'll leave open is the one for the web on port 80. Now, they'll watch it a lot, but it'll be there. However, if you try to deploy something that doesn't work over HTTP, doesn't work over port 80, you got to coordinate with system administrators, and that has to be all the system administrators between the user device and the application server. So if you're trying to deal with a user, right, and they're on the other side of say, a cable company, that means you have to get the cable company network administrators accept the port you want to use for your socket. Typically, you don't want to fool with that. So this last leg almost has to run to the browser, although browsers have gotten much more powerful. We can do a lot more with them. It talks to the application server, and what we're doing in Unit 7 is we're having the application server in conjunction with the web server. Our application, running our application server, combines whatever data sources we need together and creates a web page and sends the web page out. And there's no way to tell on the web page, on the browser. We can look at the web source, and there's no way to tell that it was machine generated and that we didn't have a little colony of gnomes sitting in our back room pounding away to create web pages manually the way you might have in high school. So, for example, when you look up your grades for this course in Desire to Learn, or whatever they call it for you, the product that we use for grades in the course is Desire to Learn. What happens is there are application programs, they query a database, they pull your information out of a database, and they build a web page on the fly. They build the HTML on the fly, and they hand it back to the browser. And from the browser's perspective, there's no way to tell that we didn't have human beings looking up what your grade was and pulling up an editor like, like you can do in Notepad, right? And writing raw HTML that happens to have your grade in it. Now, of course, that's way too expensive and difficult. But the point is the browser is completely shielded from that. That's hidden by the web server combined with the application. And we make this application web server, application server, the point that's responsible for combining our data sources and producing a final web page. So where does SOA come in? Service-oriented architecture. Well, basically what we do is we make the browser or an application running on the user device. It's typically a browser. It doesn't have to be. We can write other programs that are not browsers that know how to speak HTTP and know how to talk to a web server or go across sockets. But most often it's a browser. And what it is we put more of the intelligence out there on the user device. Could be an app on a cell phone, for example. It's still going to use, if you use your app on Wi-Fi, it's still going to use HTTP. And for that matter, even if you're using data, it's going to set it up to run HTTP over cell network instead of over Wi-Fi, but it's all going to come down to the same thing as far as the application is concerned. So we're going to make the browser or application, if it's a browser, we're going to have JavaScript code, or an application, could be an app on a cell phone, could be a Java or C# program that's speaking over HTTP. At any rate, we're going to have it be the one that's responsible for combining data sources and interacting with the user, right? We're going to put the intelligence there, and we're going to let it talk possibly to more than one data source. And each of these data sources is what we call a service. And so we'll talk about some examples of services, but the point is to make these services be kind of standalone, so that they act kind of like modules. So each application provides a service, and we don't lock down in advance what combination of services you're going to need in your application. Your application on your browser is free to pick and choose the collection of services it needs to take care of the user. And that gives us a lot of flexibility, makes things much more modular in a very powerful way. And we're going to see some of the things that are involved when we do that. And so we're going from this, where the user device basically just took care of the user interface, and we're now moving a lot of our application logic back out to the user device side of the network. This has some consequences. We lose some control doing this, but what we pick up is the flexibility and the modularity. It turns things into building blocks, and we'll talk a bit more about that in a minute. Okay, so let's go on. Here's an example, and I misspelled a word. It's funny, I've looked at these slides 3 or 4 times, and of course now that I'm in front of you, I noticed that the spell checker changed a word to something I didn't want. So my example that I'm sure you've seen is you go to some web page for a business, maybe a restaurant is a good example, and that restaurant inserts a Google map to show you how to get there. I'm sure you've seen that. Now, what this means is that the web page is combining the information from the restaurant, maybe a menu, certainly some kind of overview of the restaurant. It's combining it with the service provided by Google. So we've got 2 servers here, right? We have a server that's providing the restaurant web page. That may be fairly simple with the service that Google Maps running. And in fact, we're probably using more than one Google service in doing this. And we could have web pages that combine other things. For instance, if we have some kind of an outdoor activity, we might have a little window on our web page to some weather site that's set up to show the weather where our location is, right? And we don't want to have to write our own mapping application or our own weather application. If you're a restaurant, you don't want to be in the business of keeping the road maps for the entire US up to date, right? You want somebody else to do that. You just want people to find your restaurant. Now you could build on that old model, and you could say, well, you know, my application server, it can talk to Google, and it can go out and pull a map, and it can embed that map just as an image into the web page. And occasionally you see that, but more often we want the user to be able to do things like put in their home address and get the directions. Well, that's very hard to do through our application web server. We could have it talk to the browser and get your address and then talk to Google and build the web page and be kind of a middleman. But that's just more effort than is really worthwhile, and it puts us as a bottleneck. We're really much better off on letting the user interact with Google to do that and just having it work. Okay, and they can do other things like zoom in and out, and they can print directions, they can do all sorts of things. We provide a portal into doing that. And so here we have our web page or our cell phone app, and it talks to the restaurant website, and the restaurant website embeds a reference to Google in there, and then it also talks directly to Google. So as I do things like put in my address and ask for directions, I'm not coming back through the restaurant's website at all. I'm talking directly to Google, and my browser or cell phone app is dealing with updating the display with what Google sends it directly. This makes it a lot more modular. It lets us build specialized systems like map systems and weather systems, and we'll see some other examples on the next slide, and yet present them all to the user in a comprehensive way. Okay, so the application server talks to user devices, probably using HTTP. I mean, in theory, we could write this on sockets, but then once again, we have to have a lot of specialized software that we ship that the user installs on their device. HTTP has really become the standard. We do the HTTP over socket 80 because that's what we expect to use for web. That's what network administrators are used to. The HTTP acts as an envelope for web pages. You may not be aware of it, but when you pull up a web page, if you look at what's going on at the network level, there's more than just the HTML going across the web. There's also this envelope protocol, which is called HTTP, that basically says, hey, here's a response. Here's, you send a request using HTTP, and you get back a response. And you get back an HTTP envelope that says, this is the response to this request. Here's the content. Okay, it's a very general enveloping mechanism. It was originally designed for web pages, but was meant to be flexible. Now, we don't have to send a whole web page out every time. We can send just some more low-level data and not update the whole page. Normally, what we do when we use SOA is our content for our HTTP envelope is either an XML wrappered by SOAP. So we have the HTTP envelope, and then within that we have a SOAP envelope, and then within that we have XML. That's a common thing. Or we have HTTP with the content of JSON, and the JSON is what we call a REST service or a RESTful service, which is to say it doesn't imply state. One of the advantages to using SOAP, and you can also envelope JSON in SOAP, but one of the things that SOAP does is it allows us to keep a state. So for example, if we have a shopping cart and we put something in the shopping cart, and then a few minutes later after we look around a store some more, we put something else into our web shopping cart, we need to know that there are two things in the shopping cart, right? You really can't do that with REST, with RESTful services. They don't keep track of state. SOAP will provide you some identifiers that then allow us to build something that keeps track of state. HTTP does not do that either. HTTP uses a lot of kludges to get that effect. I know you're saying, but I know when I went to Amazon, they had a shopping cart and they let me put two different things in the shopping cart and buy it. And that's true. Doing that with HTTP, there are lots of kludges. SOAP helps us to avoid some of the kludges, not all of them. JSON basically says if you need that state stuff, we're not really the right choice. Now, both XML and JSON are just plain text. Once you get that content back and you get it out of all the envelopes, it's just a bunch of formatted text. And so as long as your program can work with text, which pretty much everything can, then you can do what you want with it. Okay? Now, XML is a little bit older, a little bit more formal. There are some industries where XML became very, very popular. XML is designed to give us a way to lay out or to model a document. JSON is a level down. It's more data fields. So if you only want one or two fields, it's much easier to use JSON. XML has a lot of overhead. It's very heavy, but there are times when it works out. So for example, insurance companies will exchange insurance documents in XML. They could use JSON. Last I heard, they really didn't. On the other hand, most people in general, JSON, because it's much lighter, it has a lot less overhead. JSON is really the popular choice, and particularly in doing these SOA things and these internet things, JSON is a much more popular choice. Okay. Interestingly, when they put this course together, they decided that they didn't need to teach JSON. I think that was a mistake, but that's for another day. You can make either work, and you can get either across in SOA. Okay? So let's move down another slide. We can have multiple SOA tiers. My last slide implied that the browser, yeah, did it? Yes, that the browser talked directly to end SOA systems, right? But we can actually stack layers of SOA. We can have SOA systems that talk to SOA systems that talk to SOA systems, right? So we may have this very involved kind of a thing. So for instance, Google has a system called Geocode, which translates street addresses into latitude and longitude. Google also has Google Maps, which take a latitude and a longitude and give you a map back. Okay. Google's mapping system may use Google's geocode for its own purposes. That could happen, or vice versa. Okay. So we can have a lot of layers wrapped out there. We could have a whole forest of things that eventually get to us. Right? We can have multiple SOA tiers. Okay, one example of something we can do with SOA is we can take a mainframe or a legacy application, and we can wrapper it up a little bit with SOA. We can front-end it or wrapper it up with XML SOAP or JSON REST, and we can make it appear like another data source. So, for example, um, initially, online banking, we built systems that pretended to be a bank in the web, and those synced with the mainframe, and that could be very clumsy. Now we can put a much thinner layer on the mainframe, and we can make it much easier to access that. Um, right? Um, your grades at Purdue Global, what you see is in Desire to Learn, but there's also a system out there that produces transcripts. I don't know what they use. I know what we use at my face job. But the transcript system is not Desire to Learn. Desire to Learn is not written to produce transcripts to say, yes, this person has completed degree requirements or not. It's designed to do courses. I could take that legacy application that takes care of your transcript and I could make it a SOA data source that could combine it up into some kind of a student information system so that you could look at an unofficial version of your transcript. Maybe your insurance company, you want to look up something about your insurance policy that runs on mainframe. We could get that over SOA. And so one of the ideas behind this SOA being a complete architecture, their idea is you should take any data source that your company has, right? Um, and you should take each of the applications and you should wrapper them up so they become a service. And so when you provide a new service to the outside or to a customer, that's just assembling as if they were modules or building blocks. You can almost hear that word Lego in the background. You can just assemble them up into what the user needs, and you can reassemble them in various ways to take care of various customers. For a long time, we've wanted reuse in software. And we've gone through different stages where we want different size building blocks, for want of a better word. A lot of early programming, we thought that first functions, then objects were going to be our building blocks. We went through a whole period with object-oriented programming where we wanted our classes to act like Legos that we could snap together to do a new application without writing a lot of code. That may be too small a level, too granular. And the argument here is no, we don't really want access to the classes outside an organization. That creates too many problems between organizations. What we want is we want organizations to provide a collection of services that you can get at over the internet. And then we want to be able to work with and use those. Okay. So these days, so for example, with my job at Purdue Global, there's a website. I forget the name of it now. I'm always forgetting its name. I always have to look it up. But for instance, they have a service, an application that acts as a service that does dual authentication when I need to change my password or when I add a new device. They have one that gets me into my employee information so I can look up my pay stubs. They have one that gives me my faculty information, like which classes I'm teaching. And all these are individual services. And when they hire a different Purdue employee, if they're not a faculty member, they don't give them the module that does their course information because they're not responsible for teaching a course. But they still give them their employee stuff, which might be like a payroll thing or an HR thing, maybe an insurance thing, and those are all modules, and we can combine those up. And they, what's behind the service, we don't really know. Maybe that was custom written to work over the web, but maybe it's just some kind of an old mainframe system that's just been wrappered a little bit because, well, if it's not broke, don't fix it. Okay. So when we go to implement stuff, normally a library is used to add and remove a SOAP envelope and return XML, and the XML is then processed doing that same library that would be used on an XML file. Back in Unit 7, where we used an XML file as a data source, you no doubt picked some kind of a library to process your UML. You could have written it just using raw strings. You could have read the string and seen that things matched up. It's a lot of work and it's standardized. That's one of the points to XML is to standardize that. People used to pass around text files all the time and parse through them. The problem is then they had to reinvent the wheel every time they came up with another file. XML does some of that reinvent the wheel stuff for you, right? And so then you can have a library that knows how to look through an XML file. In a similar way, we can have a JSON library that's used to take a data structure, and then we call it marshaling it. It takes a data structure and it turns it into a string following the JSON rules, a JSON string. JSON ultimately is just a big string that has a particular format. And it will also, the library also provides something to unmarshal it. You handed a string that's formatted to JSON, a JSON string, and it hands you back a data structure. And pretty much every language has both of these sets of libraries to it. Pretty much every language has SOAP, XML, and JSON libraries, and pretty much every language can manipulate strings. So, for instance, we can write a Java GUI application that has that prompts you for an address and then creates a HTTP connection. There's a library for that. It's like 2 lines of code to connect to an HTTP server, and then it can hand it that address, and it can get back from it a XML SOAP or a JSON entry with the map of the address, and then we can pull pieces out with our library, and then we can pull the image out that got handed back to us, and we can post it into some kind of a widget in our GUI, just as if we would post any other image, right? So we can write stuff that takes advantages of a SOA architecture in pretty much any language. However, one of the places we really notice it, one of the really powerful usages for SOA is to get things in your browser to be intelligent, like our restaurant example with the Google Map. But browsers only run JavaScript. So if we want the browser, or to put it another way, if we want a web page, because the web page is going to be running in a browser, if we want it to work with multiple sources, if we want it to do the SOA thing, then we need to use JavaScript. And in general, I'm going to say that particularly for the user device, using JavaScript with the web page is the most natural way to do it. It's the way most people have set up their SOA services to work. The second, probably most natural way is to write a native cell phone app. You can do that. That has some issues. You can use an iPhone, in which case you need to use either Swift or Objective-C, and there are a lot of libraries to work on the phone. Or if you want to use, say, Android, then you write in Java. There you have this whole big set of libraries and frameworks that you use, but you can write a Java program that runs on an Android, and it can talk and use this. You can have the native app, and I'm sure you've seen native apps and how they can be a little cleaner to the device, fit the device a little bit better than a web page. But definitely the easiest way to get this kicked up and running is to write a web page with just a little JavaScript that can do all this, because that's really what the system has gotten set up to use. And we'll see some examples of that in a little bit. So I'm going to make this a little bit modular. So I'm going to cut this talk off here, and then I'm going to provide another couple of little talks to finish fleshing out this unit. So look for the next talk.